Hi everyone, welcome. So in this session we shall discuss some organic chemistry problems. Let's see. I hope you will enjoy this session. The very first question is arrange the following compounds in increasing order of rate of reaction towards the nucleophilic substitution. Okay. So what we have these three options. We have three compounds A, B and C. Okay. And you can see the first one is your chlorobenzene, and this is your chlorobenzene with nitro group, right, at the ortho position. This position is the ortho, okay, and this position is the meta, right, with respect to this particular chlorine group. The position of the nitro is that meta, and here this is at ortho, and here this is simply the chlorine group. Okay, so what we need to understand, and what are the key points that we should keep in mind while doing this question is the basic effects. Okay, effects in organic chemistry. And what are those effects you people should aware about these: inductive effect, mesomeric effect, hyperconjugation effect, right? So these are the things that we need to keep in mind while solving this question. Okay, so let's see how to understand. The very first option is your chlorobenzene. So how to determine the rate of reaction towards the nucleophilic substitution? Okay, so when we say the nucleophilic substitution reaction, okay, this is the SN1 SN2 type of reaction. So we can talk about 2 to 3 things. Okay, what the firstly, let's see, if we have this first chlorobenzene, just remove the chlorine from here. Okay, if it will lost the chlorine, what will be the compound that it will have? Okay, this kind of the cation will be there, right? And in this case here, what will happen? This will be your like this. Okay, here we have the nitro group, okay, at the ortho position. And in this case, the third one, we have this chlorine and NO2 at the, okay, so we can also rewrite this like this. After losing the chlorine, this kind of the carbocation, okay, this phenyl ring with positive charge. Okay, phenyl ring with positive. In all these cases you can see phenyl ring is with positive charge, right? Now let's see the nitro group. Okay, so nitro group, basically this nitro group, which can also be written like this, and double bond O negative, right? So this nitro group is it act always as a minus M effect. Okay, it will show the minus M effect. Minus M effect means negative mesomeric effect. Okay, so what is the mesomeric effect? Mesomeric effect is the effect that operates between the, in case of the pi systems like the benzene ring. Okay, so it can accept, or it can donate the electrons with the from the pi, pi bond electrons can be shifted by the plus M or the minus M effect. Okay, so here the nitro group will act as a minus M effect, and if it is acting as a minus M effect, then what will be the scenario? Okay, if you see this one, so here you can see that how the nitro group will act. Okay, in the second case, if we want to stabilize this particular carbocation, okay, this is your nitrogen, oxygen, and that's your oxygen negative. Okay, so in order to stabilize this nitro will this will show the minus M effect, and minus M effect means it will withdraw the electrons. Okay, and when it will withdraw the electrons, then what will be the effect on this particular positive charge? Okay, so it will stable, okay, it will stable, or it will what, the negative positive charge will again it will increases, okay, because it will lose the electrons. So that's why this positive charge density will be high at this particular point, okay. So that's the high density here. So I think this is not the in order to be the fast SN1, the fast SN1 will be there where there is a formation of the carbocation, okay. So I think this is your positive charge much more, right? And if you see this particular C, what you can write here is this look like this is your positive charge, and this nitro group, okay, again it will act as a minus M effect. So here this is the ortho and this is the para position, okay. This nitro group is at the sorry, this is at the meta position, right? So I think the when it will go, it will delocalize the electrons. This positive charge also increases here, right? Positive charge also increases here, right? And in the so definitely we need to select the B or C first, okay. So where the SN1 will favor, okay, SN1 will favor at this ortho or at this meta. So you can see here at the ortho position, this can be the easily, okay, this electron can shift easily, this delocalization can easily happen, right, okay, at this particular case. So the B should be the highest one, okay, the B should be your highest one, right? So in the option number 4th, you can see that this B is at the highest point, and then we have the okay, then what will be the more, okay, what will be the more, B, and C should be less, okay, because it all, one more thing you can write here, that this nitro group always favors the ortho and para, okay. This is ortho para directing group, so it basically operates wonderfully at the ortho and para, okay. So here it is at the meta position, so this will not be the good one, okay. So after the B there is a suitable answer for the A, and least will be the C, okay. So very important concepts that you need to keep in mind, that this is the mesomeric effect, okay. And SN1, basically the good SN1 will be at that point where we have the, you know, the good carbocation, okay. So all right, let's move to the next question. This question number 2nd, and in this question we have the same kind of the scenario over here, okay. SN1, which one favors the SN1? So if you lose this chlorine, then what will be the scenario? This will be like this, okay, and here you will get this kind of the thing after losing the chlorine, right? Here we have the methyl group, and in the third case we have this kind of the, this is your at meta position, right, CH3. Now here you need to keep in mind that this methyl group acts as a what? It will show the plus I effect, okay. It will show the plus I effect. So by plus I effect, it will donate the electrons, okay. So once it will donate the electrons, like let's see in the second case, if it will donate the electrons towards this bond, what will happen? It will stabilize this positive charge, okay. Here you can see the good stabilization will occur, right? Good stabilization. And if stabilization is good, it means SN1 is difficult, okay. And in this case you can see here, this will also show the positive charge, and it will reduce this positive charge density, okay. This methyl group will shift the electron towards this benzene ring, and this positive charge will decreases, okay. And if it is decreasing, then SN1 also difficult over here. Okay, so I think the very first option should be the very good. So the at the first it should be the high. Now we have this A and this A. Okay, so after the first, which is better? Okay, either the C is better or the B is better. Okay, so if you see the the orthopara kind of the thing. Okay, so just remember that at this particular C, okay, this particular method, this will be the good stabilization over here. Okay, so why the good stabilization or good or bad, how you can think about this? Okay, whether which will which will stabilize this positive charge much more? Okay, can you guess which one can stabilize this? Okay, I think the stabilization with this particular meta position, it is quite difficult. Okay, it will do, but the distance from the positive charge to this group is much more, okay, as compared to this. So the C will be the second one and the B will be the least. Okay, because at this particular position it will definitely stabilize this chlorine in a very quick way. Okay, it will shift the electrons towards this carbocation. Okay, so next, let's move to the next question. Answer should be your fourth one, right? Let's see this particular question. Here we also have the same kind of the scenario. Let's move the chlorine, and this chlorine will generate the positive. Here we have positive charge. Again we have this positive charge and nitro at the para position. Okay, and here we have the again this kind of the thing, positive charge, and we have 3 nitro groups, right? Here we have the nitro group, here we have the nitro group, and here we have the nitro group. Okay, orthopara directing. Okay, so which one is more stable? As you learned in the previous question that this nitro group will act as a minus M group. Okay, this will act as a minus M group, and if it is acting as a minus M group, then what it will do? It will increase the electron it will increase the positive charge. Okay, and if the positive charge is increasing, then the SN1, the nucleophilic substitution can favor. Okay, it will be good for this. Now if you know that this nitro group is orthopara directing group, right? So this at para, it is good, and in this case you can see here this is the ortho position and this is your para. This is ortho, okay, and that's your para position, right? Okay, everything is all right. Is there any problem? I think let me write just please wait. Yeah, now you can see it. Okay, in the previous okay, yeah, so let's see the question. I think now it is perfectly visible to you. Yeah, okay, so which one should be the best as per your way? I think the very good, here it will also increase the positive charge density. Okay, it will increase the positive charge density. So I think at the C position, okay, at the C, the SN reaction should be the okay, it should be the highest. Okay, so the C should be the highest, which in this option has the C highest. Okay, and after the C there should be the B and then A. Now you can understand how it is I think you are getting the point. The more the mesomeric effect, the more will be the, you know what, more the minus m, okay, more will be more what, more positive charged, okay, more positive charge at the ring, okay. And if the more positive charge at the ring, it means Sn favors, okay, the substitution, nucleophilic substitution reaction will go well, okay. Now let's see this final question. So the answer of that question was the fourth one, okay. Now you can see the question number 4. I think everything, yeah, okay. Let's see. So in this question number 4, the same kind of the scenario you can see here. This will be your positive charge and this will be your positive charge with methyl group, okay. And here the positive charge, that's your positive charge, okay, methyl group, and here methyl group, all right. So what you can understand is these are the plus I effect, okay. So here this is your para, so this will do this kind of the, it will stabilize this, okay. So in the fourth case, in this third case, it will stabilize very well, okay. The positive charge density will be very less, okay. At this particular point, this positive charge density will be very less, okay. It will be very less. So at this it is least, okay. So in the C should be the least, okay. C should be the least, and then we have the B, and then we have the A, right. So the B will be there, okay, because it will stabilize, but then mostly this will be the highly reactive, this will be highly favors, this will highly favors SN reaction, right. I hope you understood very well. I'm just rewinding all these kind of the questions, okay, what we have started from this, okay. Always remember that in order to be the good nucleophilic substitution reaction, the positive charge should be the good, okay. More the positive charge, then better will be the nucleophilic substitution reaction, okay, because the nucleophile will come and it will attack that particular ring, all right. I hope you can see all these questions very well, okay. Thank you for watching this session, okay, thank you.